How's homework 4 going? I'm curious. Is it going okay? How many of you have started it? Okay, good. Rock and roll. Good group. Homework 4, I kind of feel like homework 4 is when the assignments kind of come alive a little bit. Does it feel a little bit more involved than homework 3? Right? Your code base is starting to grow. You're probably starting to split your code into different classes. Things are getting a little bit more interesting. I think in part because you don't really know what the user is going to supply to your code base, to your engine, right? With the homework 3, we had this kind of hard-coded situation. The only thing that could differ between runs is the inputs. But now you have to worry about the inputs differing between runs, but you also have to worry about a bunch of configuration. You have to worry about whether the user will supply rendering configuration. That is it rendering.config? Is that what we named it? You have to worry about, we could have, a few actors coming in via that JSON scene file, or you could have like many. Some of them might have default values for everything, and some of them might have everything custom, right? You have to now make your engine a bit more hardy. So for instance, it's no longer a guarantee that your player will be moving last because you update your actors in the order in which they are listed in the scene file. And so there's just, a lot more things that could happen or could not happen, and your engine has to be hardy to all of them. One quick tip, a lot of your test cases now, especially some of the bigger ones, are downloadable. You can go to your little grade report on GitLab, and you can actually, there's sometimes a blue little link that says download test case. You can grab that test case, you can put it right next to your actual executable in your repo. Don't worry, you won't push it to your repo because the git ignore has been set up for you to not do that. But you can then watch your engine explode from the comfort of your own local machine, okay? It should make debugging a lot easier. And I know for performance, that's also a very useful thing. Because sometimes if your performance isn't very good, like you just time out and you get no information from the autograder. You just time out, that's all you know. So sometimes you might want to bring a test case down locally and actually time it yourself to try and make things a bit faster before submitting it again to the autograder, see how you do. We have a really interesting game engine of the day today. This is a kind of troubled but extremely beautiful game engine. Okay, you might say this game engine is kind of all style, not so much substance, just like Final Fantasy 13. Hey, and do we have any Final Fantasy 13 fans in here? No? No, I don't blame you for a second, okay? I'm going to talk to you about why and what kind of happened on that game. But this is a Final Fantasy game engine, which was very troubled and very beautiful. It was released in 2009, and it was an engine that was kind of made to handle about 3 big Final Fantasy games. Final Fantasy has always had a reputation, or at least it did in that era. Every, new time a game console would come out, Final Fantasy would come out for the new console, and it would always look an entire generation better than its competition. This was one of the most beautiful game series in terms of aesthetics, art style, graphical technology. So Final Fantasy VIII, this is a PlayStation game, and if you squint, if you up to the resolution, it might look like, kind of a lower-end PS2 title. Has really great-looking characters, right? Some fairly detailed textures. The animations are pretty good. A very impressive engine for the time for that original PlayStation console. Then, on PlayStation 2, aside from the resolution, if you put this in HD, this could pass for, an Xbox 360 game. A PlayStation 3 game. In many cases, it looked just gorgeous. Final Fantasy X, especially the expressive and well-animated character models. On Final Fantasy 13 on the PlayStation 3, this is an old, crappy console, PlayStation 3. It is cheap hardware, right? That's the only reason the game could be $300 or the console could be $300. In when was PlayStation 3? Like 2010, 2011, I feel like. This game still has incredible character models. It has very excellent environments. I think it holds up extremely well if you go play it today in HD. Just gorgeous. And so there was always a lot of pressure on Square Enix and their technology team to deliver excellent engines that genuinely looked an entire leap beyond their competitors. But eventually, this kind of caught up with them. This requirement for graphical prowess slowed down the engine team a lot. And when you are making your own engine, that is an entire part of your team that you don't really have for the game content and the gameplay and stuff like that. What's more, if that team struggles or falls behind schedule, what happens to the game? Can you make a game with no engine? Kind of, but not really well, okay? On Final Fantasy 13, there was a big problem. The game was being made, the story was being created, the game design was being fleshed out, but the engine wasn't ready. The engine couldn't do what the game designers wanted it to do. That is a horrific problem. Because if the game designers can't get their stuff into the game and get it running, it's not in the game. It's not real. It might have to be cut. If the game designers can't iterate and be testing their stuff all the time, if everything they make is kind of hypothetical, then they can't iterate. They have to play it super, super safe. And that's a problem that this game had. This, I kid you not, is like a little guide, a little walkthrough for some of the earliest areas in the game. I think you start down here, and what do? You walk this way until you run into, what is that? I'm not sure what that is, a save point, I think. And then you keep walking forward and you run into this, a potion, and then, oop, look at this. Oh my gosh, look at this exploration right here. Is that crazy or what? Don't want to miss that. Okay, in this game, you think this is just the starting area, just the tutorial? You'd think that. The entire game is this, walking in a line until a beautiful cutscene, and then you fight something, and then walk in a line, okay? 99% of the game is that for 30 hours, okay? And it really doesn't get better. There's, I think, one area that's kind of more of a circle, an oval. You go down to a planet, and a big part of why is that the engine couldn't handle big open areas. It could not handle big cities and villages full of NPCs you could talk to, quests to go on. It just couldn't handle it. And so the game felt extremely confined and constrained and linear compared to previous Final Fantasy titles, and players just didn't like it. Okay, the game came out, got really great reviews, and then it fell apart. It has a very poor reputation today. It became a meme. Here we go. Final Fantasy 13 map of all areas except Grand Pulse, that more open area. Player spawn here. You just walk this way and watch a movie. That's it. It's the whole game. You better like these characters. You better love this story. The story does a weird Pulp Fiction thing where it's kind of taught out of order, which is a very kind of difficult choice for understanding the story. So a lot of people didn't like the story, and so the whole thing turned into a bit of a slog. Anyway, this is one of the extreme downsides, the big risks that you run when you have a proprietary in-house engine. You better hope that thing works, and you better keep that thing up to date. Because if it falls behind, everything falls behind. Whereas, what happens if you just kind of grab Unreal Engine off the shelf? What are the upsides there? Yeah.
Works.
It works. Yeah. And you know why it works? A lot of other teams have already used it. Okay? And it's already proving itself. It's already ready to go. No features are going to be added to it. You can always update to the newest Unreal, but most of the time when you start a project, you stay on that engine. Stay on that engine, and then maybe the sequel will upgrade to the next version of the engine. But also a big problem these days, you know how it's a very nice thing that other teams have used that off-the-shelf engine, have proven it's great? That's a big problem. Why is it a big problem? Creatively, artistically, if everyone is using your engine for their game, why is that a problem for you? Go for it.
It's not just for you.
Exactly. The secret sauce is out. The secret sauce ain't so secret anymore. All right? And that can be artistically and creatively a big problem. So anyway, worth thinking about, right? To keep that in mind, you may face questions asking about the downsides of these proprietary engines, the downsides of doing what we're doing. But hey, okay, even if proprietary engines go extinct, Unreal and Unity and Godot and all these engines still need people to hire, okay? So don't worry too much. Okay, some announcements. IGDA Ann Arbor is this Thursday. Just a reminder, Warner Brothers Games is going to be in town. Sean Pride of Warner Bros., also of the MSU Game Dev program, great program. You're going to be talking about AI, talking about NPCs. I'm sure he's going to be fielding questions about LLM usage in NPCs. That is one of the areas that a lot of people think LLMs, AI, could have a lot of impact in games. Can we auto-generate interesting interactions for our NPCs in an unlimited sense? Now, if you've used ChatGPT, I don't know, maybe you feel the way I do. You're like, I don't feel so good about this. Okay, you have one conversation with LLM. You kind of have had all the conversations with that LLM, but we'll see how it goes. A lot of money riding on them figuring that out. A really cool Reddit post here. Let me see if I can grab it real quick. Okay, a really cool Reddit post I found on the topic of Age of Empires. Kind of an old school kind of StarCraft or Warcraft style RTS. And it was a very well-received RTS on very old PCs. They had tons of units, and they had a lot of other really fancy features. I think they had replay support. And what's really great is a lot of the legends who made these really impressive early titles and this groundbreaking technology, they are still alive. Okay? They are still around. You can email them. They're probably sitting around bored. Some of them retired hoping to tell people stories. Okay? That's just kind of what old people do. So it's one of those things that, like, if you have no fear and no shame, you just go so far in life. I've known some people like that. I would be terrified to, like, send Sid Meier an email. I've done it a few times. But, like, people who just have no fear, they just do it, and they reap all the rewards. It's amazing. Anyway, one of the original devs of this series finds this Reddit post and just comments on it. And talks about, yeah, I can clarify this. I wrote all the assembly code used in Age of Empires, along with many other parts of the games. Oh, hey, you know, what a coincidence. And he kind of talks about why they did what they did. I think, if I recall, it's been like a year since I've read this myself, but if I recall, a big part of it is that assemblers at the time, compilers at the time were good at some things, but not very good at optimizing, like, rendering related code. So they had to kind of go in and handcraft rendering related logic via assembly for, I think, a bunch of different machines. But because they did this, their rendering performance was vastly better than some of their competitors at the time. And that's part of the reason they used a lot of assembly on this particular project. These days, compilers will, like, usually crush humans when it comes to writing optimized assembly, but it can still be very valuable to learn assembly and poke around at it just to kind of have a feel for what your compiler is doing under the hood. I'll say Optimization has become a bit frustrating in modern times because compilers have so many optimizations they can do, and it's a bit hard to predict what they're going to do and what they're not going to do. And being able to look at the assembly and watch and see what the compiler did can be very useful. But also, you may think you've come up with a brilliant optimization. Make sure you test that, because sometimes you will be incorrect. A story I always remember, a general heuristic is that you want to keep your data types as small as possible. Making them smaller will often speed you up. Why? Well, if you have a really small data type, your cache is going to be able to load more objects into memory at once, which will kind of decrease your cache miss rate, which will speed everything up. I can't remember if I told you this story, did I? I came up with an optimization where I realized that for a certain variable, I only needed an integer range like 0 to 255. What does that mean? That means I don't have to use integers, which are 4 bytes. I can use just a byte. Okay, I can really optimize that. So I think I used a data type called uint8, which is like, this is a data type, 4 integers that is like required to be 8 bits. Yeah, 1 byte. And I'm like, yes, oh my gosh, I've made this so much smaller. We're going to get a big performance boost. The students are going to be like, they're going to be so happy to hear about this cool optimization. They're going to have to optimize even harder to hit the points, right, in the homework. And so I submitted it to the autograder. Super excited to see how much I improved things. How much did I improve things by? 30% slower. I'm thinking like, what? No way. No, this can't be correct. What? This makes no sense. Well, it turns out if you use integers, they're such a common data type that usually the compiler can do a lot of very fancy, like low-level hardware stuff to speed up that kind of operation. But if you use a kind of a less common data type like uint8, the compiler is less likely to use those hardware optimizations, might accidentally not use them at all, and now you're dramatically slower, despite heuristically kind of doing something that tends to speed you up. All right. Maybe the most important optimization technique you can use in this course is just remember to test, iterate often, and test out things. And it's very frustrating because I really want students to be able to come away with useful heuristics. Like, only use the data that you truly need. But then we have a result like this, and it's like, well, I guess don't do that, right? Okay, it's messy. Just know it's very messy. And this is where it starts to feel like a genuine computer science, because we need to experiment a lot to figure out what's going on and to make things better. Okay? All right, anyway. Read the rest of that Reddit post if you want to. Lots of really good stuff on the internet. We're very lucky to live in the era we live in many ways at least, and maybe in some ways not so lucky. But all right, quiz number 2 is on Monday, and I know you're very excited for it. Discussion section, I think we'll be talking about some topics to kind of make sure that you are in good shape for that. But the topics are going to be kind of related to a lot of the stuff we've been talking about recently, and I think some of the stuff we're going to talk about today. Those kind of 4 core compilation questions. Do you remember what they are? Headers. Where should I look for them? And which ones do you want? Simultaneously, on the library side, the static stuff, okay? Where should I look for libraries and which ones do you actually want? Those 4 kind of fundamental questions to your C++ compilers, you're going to see them everywhere. When you go and learn a meta build system like premig or cmig, okay, you're going to see exactly those questions. You answer them, and then it's going to take care of you and make sure you can compile. Other fun common bug classes like pointer invalidation bugs, memory-related bugs, which we talked about last time. We're going to talk about some more of those today. Today we're going to talk about shallow copies versus deep copies, which is kind of a fun thing that can bite you on homework 4 and I think especially homework 5. We're going to talk about game loops. We're going to talk about scene and actor templates. Templates are kind of a pretty important thing, only going to become more important as our engines become more interesting. We're going to talk about the standard containers on the quiz, because those are things you should be kind of reasoning about now. Should I use a set? What about an unordered set? What's the difference in complexity? Vectors, stuff like that. We're going to talk a little bit about pointers versus shared pointers. I think this one's really light because we didn't talk too much about smart pointers last lecture, so I think the quiz will take it easy on you. STD optional is something I think that we will hit today. Just to make sure you have a little bit of information on it. STD optional. Have you ever had a data type where a certain value is said to be not set or invalid or don't have a value? A common thing is like integer, age, and you set that to a default -1 because -1 in your program means that you don't have an age. Have you ever used a C-style API, usually an older API, where it will return a number, and if it returns -1, that's an error condition. The function actually failed. It might not have crashed, but it failed. Have you ever seen something like that? Right? So I think these are typically called sentinel values. They're a value that is like not valid. And sometimes, riddle me this. I have a health value. It's an integer, but sometimes the actor doesn't have its health read in yet, or you haven't loaded it yet, it hasn't been configured yet, or it just flat out doesn't have a concept of health. What number could we use to represent a health that means invalid health, or not yet decided? Could we use a number that would make some sense for that? What's a number that might make sense? Maybe. Yeah?
Like a really large negative value?
A really large negative value. Yeah, makes a lot of sense, right? I would say any negative value, or a -1 makes sense. Usually, health has a kind of logical gameplay range of 0 to some large number. Sometimes 100 for 100%, but in RPGs you can level up, maybe you can go way beyond that. -1 is an excellent sentinel value to mean not yet ready. We don't have this information. Okay, I have another variable, integer X position. What can my sentinel value be for a X position variable that is an integer data type? What's a really great, like, I haven't set this value yet value for an X position? Yeah.
You could just go with 0?
You could go with 0 to indicate that the value hasn't been set yet, and maybe we should go look it up from the server or the file. But that's a bit of an issue, isn't it? Because 0 is also a valid place that it could be loaded. We could actually, that could be the genuine value, right? So 0 is probably the best choice. It's an awful choice, right? It doesn't really work, yes?
If your map is continuous and every position in X coordinates are valid, then you don't really have a good choice.
Exactly. Your best choice is probably like the max integer value, because hopefully we don't have players running around way out there. I know in EECS 298 I did a very bad thing, very naughty. Don't do what I do what I say, don't do what I do. For some values I set like XYZ 999 999 999. That is the location I take you when you die. Okay? Because I'm pretty sure no, student is going to create level design that takes us all the way out there. But they could. That's a valid thing to do. And if they do, they're going to get blown up. And it's not their fault. It's my fault. Okay? Yes?
If your position is a float, can you use
Which one?
if your position, X position is a float, can you use...
Like infinity?
Yeah.
I don't know very much about those values. I would suspect... I wonder if that is just... I would kind of suspect that that is just a value that's been chosen arbitrarily to mean infinity. And it's probably mapped as like an actual legit number under the hood that could be found. I don't know. Well, do you know how that's implemented? Infinity?
As far as I remember from personality, it's like it's a special case for
Okay.
float, but it's not a valid number.
This is not a valid number. So that would be a sentinel that was built in. Yeah, cool. That would work. So what you can do is you can wrap your data type in something called STD optional. And STD optional is kind of a wrapper that's going to include basically a Boolean that says, hey, has this been set yet? Has an actual value been received? And you can also kind of check this STD optional wrapper object to check if it's valid yet or not. And this is kind of a way of encapsulating a data type that would kind of struggle with having a sentinel value. It kind of gives it one. So that's something to know, and it might be useful to you on homework 4 or homework 5. Okay? But kind of a useful thing in general just to know it exists. Another kind of useful thing here, and this is just kind of a mini lecture. The topic of composite keys. So when many of you are using an accelerating data structure, or you're actually just using, you're using something like a render map or a collision map. You're using an unordered map or an ordered map in order to basically say, I have an X as a key, I have a Y as a key, and I want to use that X and Y to key into a list of, objects that are at that location. Okay? I think we talked about that kind of accelerating data structure last time, and it's very natural to do that. The question, though, is how do you actually set this thing up? Because there are quite a few options, as it turns out. You could have this, oh my gosh, this massive beast of a data structure, okay? This is an unordered map that is keyed on integer. That's our X. And then that can give us an unordered map that has a key of integer. That's our Y. And then we finally have our list of actor references, okay? Which could be empty. It could be super full, all right? We don't know. But I'll tell you, this is a pretty hideous thing, okay? And we're also going to have to do 2 kind of lookups in order to get this information. Probably super fast, but, not as fast as it maybe could be. One thing you could do, and I think this is what I did early on, because it's just really easy, but it's kind of slow, is you could just have a string. That could be your key, and you can kind of concatenate your X and Y value, maybe with a comma or something else, a dash between them, and that can be your key. And that key is going to get you straight to your actor star array or your vector, and there you go, right? Pretty simple. What's the issue with this? There are a couple things that are really nice about this. It's probably very easy for you to program. You can just get this going right away, okay? Probably not that great, though. Why?
String hashing is really slow.
Yes, that's right. So the way that these maps are going to work, this is also, I think, the way that sets work, and why they are O of 1 kind of lookup, is that they're going to take your data structure and they're going to run a hash function on them. And for kind of numerical types, this tends to be like lightning quick. But for strings, right, strings can be quite long. They are often on the heap, and they can be very, very slow to hash. So this is probably going to be very nice from a correctness standpoint and just prototyping, but probably not how you want to leave it. In general, game engines, if you look at the optional book for this course, game engines don't like having strings running around and flowing around inside of them very much due to that kind of slowness. And I think Jason Gregory's Game Engine Architecture book actually has some cool techniques for how to replace those strings as kind of a pre-compilation step with kind of integer, like numeric IDs, which are then kind of looked up later. So kind of interesting stuff. You can look it up if you want to. Something you could also do is std unordered map pair of int to vector star. The one that the instructor solution uses I think we determined experimentally that this was the fastest. And it's kind of interesting. I am pretty awful at bit manipulation. I just simply don't do it that often. But what is happening here in this function is we're basically, we are taking a kind of 32-bit data structure, and we are kind of packing our two integers into that. So, actually, no, sorry. We have a double, a 64-bit data structure. We're taking two 32-bit ints, and we're actually like putting those into the same data structure. So, okay, we have int x, y. We are casting that to 32 bits to make sure they're 32 bits. We have the 64-bit result, which is what's going to be coming out here. When we put the x into it, it's going to go into the kind of rightmost 32 bits. But we can shift those over to the left to make space for putting the the y in at the 32 bits. The result is that the left 32 bits has the x, the right 32 bits has the y. And so we've kind of done the same thing you were doing with the string, but we've done this just kind of numerically. We've packed this information in. And so we have this type that hashes like really quickly, and you should be able to go in and use it as a key if you want. So kind of fun. Yes?
Why not just use a custom hash function?
A custom hash function. Could do that too. Yeah. All right. So you can decide what you want to do. And I think the most important part, though, is that when you make that decision, do some experiments, okay? The autograder provides a pretty nice way to run experiments, but there is some variance in the autograder. In my experience, it tends to be like 10 to 15%. We run your code about 10 times and then take the median performance there. Sometimes I wonder if we should try and run it like 100 times for the fast test cases. The problem, though, is that the longer test cases then just bog down everything and take a very long time. So, yeah, oh well. Hand up?
I got this.
Okay, cool. So there are lots of kind of interesting small topics like this. I encourage you to look at it. You never know if it might show up on a quiz or on the exam. But if it does, I'll let you know. There's some more interesting kind of performance-related things you should look into on homework 4. We give you some JSON loading code. We just give it to you on homework 4. You can study rapid JSON yourself and load things yourself. I think we don't have the absolute optimal loading algorithm or loading technique, but it's pretty fast. And so there's a good chance it's going to be faster than what you write yourself. And so if you want to just grab something off the shelf, you can grab that. Just look in the assignment spec and you'll find it. When you want to performance test, you can use features from STD Chrono in order to get, I think it's called a stopwatch data structure, which has some nice functions. You can basically create the stopwatch, tell it to start, and then you run a function, tell it to stop, and it will give you the amount of time that has elapsed in some pretty fine detail. And that's a way that you can kind of measure your performance locally if you want to. There are some very interesting topics when it comes to kind of preventing copies from being made. And STD move is kind of a slightly dangerous technique. Let me see here. So you have some structures that you are creating, and let me see, we use STD move here, yes. Okay, so when you have an object like new actor, let me see, where's that created? You're creating this object new actor right here. And you are doing some stuff with it, you're doing some work. You want to eventually put that into some sort of database, like we talked about last time. You can see that happening here. We have this actors array, which you saw last time. We're pushing it back, new actor, right? But actually, when you do that push back, you may be creating a copy. New actor is right up here. And you might have some logic down here that might be using new actor. Maybe the compiler doesn't quite know, right? And so one thing you can do is you can use std move, and you're kind of telling the compiler, hey, I want you to try and avoid creating a copy and just kind of insert it directly into the actor array as efficiently as you can. What's interesting about stdmove is that as soon as you use stdmove on this variable, new actor, it is no longer valid to reference or use or manipulate that variable after this line of code. So this is kind of dangerous. You will start to get weird behavior or crashes if you mess with new actor mistakenly down here. But sometimes you can get the compiler to optimize a little bit harder if you use stdmove to get things to where you want to go. What else? You do not need any exotic data structures or anything we haven't talked about in class. The performance requirements for homework 4 are a bit tighter, but they're not crazy. In general, nothing in the course is that crazy. Maybe homework 6 and the collision detection stuff. But it shouldn't be too bad this week. If your engine never gets fast enough, if you're not getting all the performance points on a homework, don't lose too much sleep. Okay? You might struggle on future homeworks performance-related test cases, but probably not, right? You are going to be changing logic and removing and adding features every week, and so I wouldn't worry too much about it. And you gain more time to optimize in the future as well, so you can try that. Okay, some quick debugging tips. If you haven't, C++ has a lot of ways to kind of get you blown up, ways that are subtle. The classic one is like uninitialized variables. And I recommend going into, for instance, if you're in Visual Studio, going into your project settings, C++ general, go to your warning level, and choose a pretty strict warning level. This is going to get the IDE to look through your code and warn you very harshly about anything that might be undefined behavior, anything that's kind of unusual that you're doing that might get you in trouble later. Sometimes third-party libraries will have a lot of issues like this, warnings showing up that you just can't deal with. I think this is GLM, big integer data type. There's just like, yeah, don't go in and try and fix this, okay? Don't worry too much about your third-party dependencies. You should look at the warnings tab. You might have 6 errors, you might have 0 errors, but you should have a warnings tab of some sort in Visual Studio that you can kind of look at. And if you're seeing any warnings from code you wrote, you really want to take a look at those and see if you can get rid of those. Here's an example, right? My actor data structure has a velocity value. It is uninitialized. Could cause problems. In general, if you have a single-threaded program that is like just flat out doing different things every time you run, sometimes it crashes, sometimes it doesn't. Sometimes I get this result for the exact same input, sometimes I get this different result. That is scary stuff, and in many cases, especially in this course, like it's probably some sort of undefined behavior that a warning in your IDE is probably trying to get you to fix. You just have to pay attention to it. I have to imagine Xcode has something similar, but it's a pain in the ass, that UI. There's something called the undefined behavior. Gosh, I think it's, what is it? It's not analyzer, is it? But just do some Google searching and you'll find it, and hopefully you can watch a video and get that working, okay? I think Linux has tools like GDB and Valgrind that can help you with that side of things, if you're on Linux. I think CLine, if you use that IDE, should help you out quite a bit as well. Okay, anyone have any questions or comments on any of this stuff? Okay, so what I want to do today, because we are getting a little bit closer to making something, more resembling a Unity or an Unreal, I want to talk about how scenes tend to be represented. And then we're also going to talk about some common kind of memory issues that can happen as well. Who knows what game this is right here? Anyone? Okay. Which game is it? Elden Ring. That is a gigantic game. Absolutely massive, okay? And when you say, like, well, if you look at a scene like this, what do you actually see, okay? As engineers, you probably see actors, vertices, faces, meshes, right? Shaders, templates. you see other technology kind of at work bringing the scene to life. But what users are typically going to see, right? Stories, characters, relationships, moments for progression, okay? It's very interesting to imagine that different users are really going to see different things. And it's important for us engineers to not get too lost in the weeds, okay? It's very easy to forget how magical these experiences can be for our end users. But we still should ask the question, how exactly do we go about efficiently representing all of these different things? There are a lot of trade-offs depending on how we structure that and what kind of file formats we choose and stuff like that. When you look at an editor like this, when you look at the scene, beyond all the nice graphics here, what do we actually have? We have a scene, right, some sort of list structure that, at least in this scene over here, is trying to represent three different actors. We have a main camera, right, that's why we can see into the scene. We have a light, that's why our object is shaded, and we have our actual cube actor. Okay, you can see them all here in the nice little hierarchy. And you can also see it in the 3D view pane. So we have three actors, okay? How do you describe those actors? Well, you can give them names. You usually want to, because at some point your game designers are going to want to reference those and manipulate them, change them. Okay, we have a name, and you can see it right up there. Main camera, directional light, cube. But we also have other data as well. In Unity, every object is going to have a position, rotation, and scale, usually packed up into a transform component. But we'll be working with components in Lua during homework 7. We're not there quite yet. Okay? We have a lot of other stuff too, right? We have a lot of different data. We have a data based on collisions. We have data relating to how something is going to be rendered and all that good stuff. So, in order to represent this stuff, we might want to choose a data format. You know, which one should we choose and why? Do you have any ideas, by the way? What could we choose? What did we choose on homework 4? Okay, we chose a very developer-friendly one, not a very performant one. Sai? Yes, exactly. We chose JSON, but there are other options. Does anyone know what Unity chose? This is like one of the few areas where we actually kind of diverge from Unity. Yes?
YAML, and I know this because Git merge comes from last semester.
Exactly, YAML. Okay, YAML is what we use for Unity. Does anyone know what Unreal Engine uses? Hardcore as they are, they did not use a human-readable format.
Assets?
They use something called the .u asset, which is kind of a proprietary binary blob format, right? And they do that for efficiency reasons, okay? So when we look at Unity, okay, oh, and this is my hint to go actually do this. Let's take a look at an actual Unity project. So we can go into this Unity project. I actually think I'm going to try and load it up in Unity in the background so we can take a genuine look at it. Let's see how that goes. See how long it takes to open. Come on. Hello. Unity used to be extremely fast. Now, like, Godot has that reputation. I think it got very bloated. I was talking with did anyone talk with, with Mark yesterday? So Mark worked on Avatar and some other really, really cool things. He's a mocap guy. He worked for Weta, which I think did Lord of the Rings special effects. And he's got some words to say on Unity. Unity bought Weta and has made a lot of very poor decisions. I think we talked about some of them in our first lecture. But while this opens up, what I want to do is I'm going to go into the assets folder. I'm going to go find a .scene file. Here's sample scene.unity, 14 kilobytes. Let's go ahead and open it up in Notepad++. If you don't do this very often, I highly recommend when you see a new data type, when you see a new file format, open it up, not in the program that consumes it, but open it up in any kind of general text editor. You can find some kind of interesting things in there sometimes. When you look in the .unity file, you can see that this is YAML. often file formats will begin with a line that kind of describes what the format is, and often what version it is, 1.1 in this case. We can see that in here we have some project-oriented settings, occlusion culling settings, render settings, fog. Okay, fog is a setting that isn't really tied to any particular game object, but is tied to scenes and stuff like that. How's our Unity doing? Oh my gosh, it had a pop-up. Okay, so we'll give it a little bit more time to rock and roll. In this file, as you go down it, you can see that it is human readable, but is it? What do you think? If you had a merge conflict in this file format, how easy would it be for you to fix this? Do you have any experience with this?
Yeah, it's not easy.
No, it's not easy. You can kind of sort of do it, but you also risk kind of messing things up pretty badly as well. Let's go into this sample scene. Oh, come on. When it finishes here, and you know what I think I'm going to do? I'm going to get Unreal Engine going as well. Okay, just so we can kind of see. I'm also going to get Godot going as well, just so we don't have to wait. I got all the engines here, all right? An interesting little insight into course design. We don't have a kind of cohesive, right, program for game dev at the University of Michigan. Do you know what we do have? We have a lot of courses kind of scattered around the university, a lot of them in computer science, a lot of them run by one guy. And as a result of this, let's see here. Hello, can I get this in here? Okay, here it is. Open up, please, thank you. Okay, import, convert the full project. Yeah, sure, why not? Go for it. Okay. Because of this, we do have a philosophy where each course tries to use a different game engine. Why would we do this? So EECS 494 uses Unity. You go very deep on Unity. EECS 440 does Unreal Engine. Okay, and the upcoming EECS 498, the MMO architecture course, is going to be Godot based. Why would we do this? What's the point? What's the takeaway? It's kind of a pain in the butt managing 3 or 4 different engines, right? What's the point?
They're all used like extensively in the real world.
Yeah, they are useful, viable engines. But we could just learn Unity or learn Unreal. That'd probably be the choice for industry. Yeah.
Is it because they're all kind of the same underneath the hood, and so you're getting experience with all of them?
Exactly, right? We are trying very hard to convince you that almost all integrated engines are just about the same thing under the hood, okay? They all provide you very similar features. So Unity is taking here it is, okay? So we are in sample scene. We have 2 cubes. We have one game object called special cube, one game object called cube, directional light, and main camera. The special cube is actually a prefab, so it is linked to kind of another game object that chills down here in our project pane. And I think our mission has got to be, we're in that sample scene.unity file, can we make sense of any of this stuff? Can I find that special cube? And I hit enter and look at that, okay? I found what looks to be this little object, kind of denoted by this. I think this is a comment in YAML. Okay, everything looks a little bit different. But we have a game object that says it's a prefab instance. Well, what is it a instance of? And we see this name right here, special cube. Can we find what it is a prefab of? I wonder where that information is. We got all of these property paths. They have names. They have values associated with them. I think I want to, source prefab right here. Something with the file pre-ID this, okay? The GUID this. That's crazy. I can't read it. I don't know what this means. You know what we can maybe do, though? Okay, hold on a second. I want to move this special cube, this tall cube, over to the right, but I don't want to use the Unity editor to do it. So can we find local position.x? What happens if I just happen to change this to 5 and save the file? What's going to happen? Unity freaks out and goes, oh, the file changed, but I didn't change it. Reload. Oh, okay. Pretty cool, huh? You're going to be doing a lot of this, by the way, because you're going to have a file format for your scenes, kind of like this, and you don't have an editor, a visual editor, to edit it. So you're going to be editing some of this in a text editor. You can add and create your own visual editor if you want to in the final 2 weeks of the course, your custom feature. But look forward to that. And so, right, all this stuff, everything you see in the scene visually is in this file right here. And you can mess with it. You can see it is human readable. If it is human readable, it's probably not very efficient, is it? That's one of the big downsides of having a human readable text format. So, right, what does Unity use? It uses YAML. This is a good option for representing scenes, representing prefabs, representing metadata for objects, templates. It stands for yet another markup language. And it tends to look something like this, right? You have a normal game object. You have a list of components in what looks like a map, okay? That's a huge hint, actually, for homework 7. You have a name, you've got tags, you've got isActive, which is the little checkbox in the corner for all of our 494 devs. The official website is written in YAML, okay? This isn't a HTML. This is apparently YAML, which is quite cool. The expressiveness of the language is very impressive. Released in 2001, it is kind of a minimal syntax compared to what we will see in XML and JSON, but it is extremely fully featured, okay? This is XML right here. Okay, just kind of compare the two, and this is actually expressing, I think, quite a bit less data than this is right here. Fewer fields, but my goodness, this is massive, okay? It relies on white space, right? Indentation, kind of similar to Python in that way, which can cause evil to occur, right? You start mixing spaces and tabs. That's kind of the classic error that happens. But it has some really nifty features that a lot of other formats don't have. Number one, it actually has comments, which is a killer app feature, if there ever was one. JSON does not support comments, okay? You know how you add comments in a JSON blob? You could do it. It's really hacky.
You can just bring your dummy variable.
Yeah. Yeah, you take your JSON object, you give it a dummy field called like comment for whatever, and then you can write in there and just hope no engine or application tries to parse it, right? Commenting is a really killer feature. You can use pound. I think those are comments as well, but I'm not entirely sure. You have comments that can just be inline. You have a really powerful feature called anchors and aliases. This allows you to write some markup. It allows you to write some markup. And then, the anchor, which defines a chunk of config. And then you can use star to kind of reference that elsewhere. So kind of a pointer system that allows you to kind of cut down on duplication. Here it is, okay? So build test is right here. We're defining this object, okay? It's an anchor, it's going to be reusable. So you have this ampersand right here. You then have this star build test, which is referencing this object right here. So it's kind of like when this gets read, you're copying and pasting this block right in here and right in here. And this, you can see, it allows you to cut down on the amount of markup you have. It also allows you to avoid violating dry, which is a principle, a really important one we talked about earlier, okay? You can have references like that, which is pretty cool. References to a template. You can do all sorts of really cool stuff. Question, what kind of format does Unreal Engine use? Any ideas? So this is another one where I'm going to kind of try and get this. Oh my gosh, I don't want to log in. Log with my Disney account or my Lego account. What? Who? Have you ever seen this anywhere else? Like they wasted time implementing this. You can also, you used to be able, you can use your Nintendo account too. That's kind of crazy, isn't it? So I'll just open up the file format because I don't have a whole lot to show you in the Unreal format for reasons you're going to know in just a sec. Let's look at uProject file for a moment. Okay, this one is nice. Okay, what file format is this? JSON. All right. Okay, so when people ask me why I chose JSON for our engines, say like, because Unreal Engine did it, right? And they're the best. No, okay, this is actually not a scene file, okay? This is not a scene file. It would be way bigger than this. This is just like some project metadata. That's it, okay? So actually, I can't even say that I did things right. Here is our level1.umap file. This, I think, is the kind of equivalent of a scene file. Let's open this thing up and just get ready. Oh yeah. Have you ever seen this and like wondered what's going on? Like, whoa, something wrong happened. What actually happened here?
Is it binary trying to be parsed as UTF-8?
Yes, exactly, right? So we have a binary blob file that is absolutely not meant to be looked at by humans, okay? This is the kind of file format that is written by software, by tools, and is consumed and read by software, by tools, okay? But one really nice thing about this is that your tools can read this kind of format very quickly. And if you can pack information into binary blobs, then you can typically get a very nice reduction in size of the file. You can also often load information much more quickly into data structures so you can then start doing things. So this can be extremely efficient in loading times and size. And you know what this makes me think of? One of the big topics, actually, in the MMO course that I'm designing right now, and I'm experimenting with it and learning, message protocols, okay? Have you ever heard of Google protobuffers? Okay, a little bit. If you go to a big hardcore studio, or if you go to a heavy client server kind of shop, often you won't use JSON to communicate between client and server. You'll actually use a binary packed format. Why? Because your messages in JSON might be 5 kilobytes, and if you pack it into binary, using Google protobufs, you can get that down to maybe like 1 kilobyte. That's a big deal, especially for networks, because smaller payloads can often kind of route a little bit better, and they can get through the network a little bit better. They get reassembled a little bit better. They just have fewer problems passing through different nodes in the network. So reducing your payloads is a really, really big deal. On the Sims 4, Sims 4 was going to be a MMO. It's going to be a big multiplayer game. And we couldn't, the designers, it's very strange development because the engineers started making this setup, and the designers never quite figured out how to make the Sims gameplay work in a shared world, like in a multiplayer world. Because a big feature in The Sims is the ability to fast forward time. If all of your Sims go to sleep, it doesn't just fast forward, it quadruple super fast forwards. Because it's really boring to just watch your Sims sleep. Well, you can't do that if your Sims have gone to sleep, but other Sims in the map have not. And so, figuring out how to get that temporal element of gameplay to work, we just couldn't figure it out. And then the SimCity debacle happened where no one could log in to the login servers, and that game collapsed. That franchise is dead. And we had this multiplayer game that now had to become a single-player offline game. When you launch The Sims 4, does anyone have it? Hell yeah. Okay, 30 million copies. It's my best-selling game. Okay? I do not deserve credit for that. When you launch that game, it is the world's smallest client-server program. Okay, it's the world's smallest MMO. It is launching a client process and a server process, and they communicate via Google protobufs, back and forth to make that really fast. Now, we ended up not benefiting from this because it's a single-player game, but we have a multiplayer architecture. But that's how it goes. Okay, a lot of things in that game's design was affected by the idea that we're going to go heavy on multiplayer, and then we pivoted and dropped a lot of that, and that has big effect on the game, the final game. A lot of fans were confused as to why it was so different from The Sims 3 and why we dropped so many features, and that was why. But, players don't know that. And they don't care, and they shouldn't have to care, right? Okay, anyway, we have in Unreal, hey, Unreal Engine, no surprise, they're going for efficiency, they're going for gigantic worlds, they choose a binary file format, an excellent idea, but it does make things like debugging a little bit harder, okay? All right, so custom binary file format. Here is your scene right here in Unreal Engine, just gorgeous, look at this, right? It just got 2 cubes and it looks amazing, all right? That's Unreal Engine for you. We have a custom binary format. It is messy. I always love looking at the binary formats because sometimes you can find strings that are human readable, and it's just kind of fun to imagine how things are structured. The benefits, right? Very performant. But the downsides is that development tends to be a bit more of a pain, and you have to write specific tools to kind of dissect them when something goes wrong. Godot is kind of it's very indie. Okay, what they chose to do. Let's look at Godot real quick. I opened up this project, and maybe this changed in Godot 4. But what I'm going to do, integrated engines always give you a way to look at your project and its assets, the things that comprise your reality. But they also almost always do this. Watch this. I'm going to right-click down here, open in File Manager. Unity has this, Unreal has this. Right-click on the thing, show me the thing in my native File Manager. Mwah! Super convenient, super useful for finding stuff and fixing stuff. We have in Godot the project.godot file. I think this is pretty much just a wrapper. Yeah. We have some basic information about our project. What file format is this? Godot 4 fixed a lot of the weird indie flavored things that Godot 3 had, but didn't fix this. Yeah.
Maybe either Tamil or CFG.
I'm fairly certain that this is like just their own thing. But CFG?
I was thinking INI, not CFG.
Okay, INI. What is INI? That's like a Microsoft format, right?
So.
I'm really curious, actually. We need to make sure we don't run out of time for the shallow copy stuff because it is on your quiz. This vaguely looks similar to it, doesn't it? This might be INI. Are you kidding me? That's crazy. That's an old file format, though, isn't it? Weird. Does it do comments? Does it support comments? I don't see any comments. This might be like a souped-up INI or something like that. I'm not seeing any comments in here. Oh, here we go. This is totally INI. Well done. Good job. All right. So, really, really good stuff. But we have INI in here. Kind of a strange choice, but at least it is a standard. And you've got a bunch of kind of sections in these brackets, and then you've got key value pairs, very, very common in a config format. But let's keep looking, okay? We have level1.tscn. This stands for scene, SCN. Do you know what the T stands for? Yeah. I think it stands for textual. Because I believe Godot has a binary file format as well, but the textual format is INI, so human readable. In this scene, we have a scene, okay, we have a reference to a script resource at the very top. We have a box mesh resource. We have a Node 3D resource here. We then have a pretty cool one, name. It actually has a name. Ground cube. So let's see if we can find that really quickly. We have a ground cube, and when I click on it, it is the big cube that's just chilling here. This scene has 4 nodes. A node to represent the entire map, okay? We have a ground cube. We have a player camera, which we can see right over here. It has some rotation to it. Why on earth is it like a box? What on earth is that? Weird, okay? It has a player light. Oh, it's because the light is over here. Yeah, okay. So it's considered part of the camera. So let's keep looking down here and see if we can find anything familiar. We have the ground cube, which is of type Mesh Instance 3D. And I think we can confirm that. We click on the player camera. And we're going to find, no, ground cube, sorry. And up here, mesh instance 3D. Yep, so we get a bunch of data from that. Let's keep looking down here. Custom property. There's a custom property somewhere on this object. Can we find it, I wonder? Mesh skeleton, node 3D, geometry instance 3D. Do you see it anywhere in here? Hello? Editor description, in here, physics. I think it would be down here. Custom script, but I don't think it's loading. We have an export string property. Can I build this? Let's build it real quick, and I think maybe then we'll be able to see it. Okay, come on, let's go. Chop, chop. Okay, maybe I spoke too soon for Godot. Okay, here we are. Let's look at ground cube. Let's go to the inspector. And do we see it in here? I'm not sure. Oh yeah, right up here. Okay, custom property. It's right at the very top. Custom property, and it says hello students. And so we can see that we are representing not only our objects here, our nodes, but also the properties of those nodes via these kind of any key value pairs underneath the object. We have transform data. If we move this stuff, I'm guessing it will, change where we are. We have the light information. Yeah, what you'd expect. It seems to be a pretty decent file format. Human readable, which means not very efficient, but good for development. Godot isn't very efficient in general and not very high performance, so probably a good choice for them. Option 2, right? No, sorry, that's Unreal Engine. Godot, right? We have these objects, these nodes. We have a .tscn file, textual scene file, which is basically in Godot. This is a prefab, but it's also a scene, okay? In Godot, Godot does not make any distinction between scenes and reusable things like prefabs, templates. In fact, it's pretty much nodes all the way down. A node can be your map, a node can be a prefab, a node can be a component, okay? It's very interesting. It's kind of recursive. But we have level 2.scene. The format is ini. So me making fun of Godot is not valid anymore. But basically, you choose a standard textual format like JSON for stability and reusability, for ease of use, for libraries, okay? Choosing custom textual formats is a very weird choice. You usually don't do that. I thought Godot was doing this, but they're using ini. Choosing a really old format like this is weird. It's very strange, but it's fine, okay? Godot can do what they want. These nodes are basically actors, but they're also components, they're also scenes. And you can see that they line up to what we see here. Parenting is kind of a big deal here. These nodes have either a parent property if they are parented to something above them, or if they have kind of nothing above them, or just the default one, spatial, then they'll have just a dot for their parent, which is kind of interesting. Okay, so there's a file format here. There's a description here. I'm surprised. Look at the file format. Oh, it's broken. Okay. That's extremely indie. Description here. That's extremely indie too. Sweet. You notice how it's just kind of like going for it? It's like not giving up. All right? It's just refreshing, refreshing, refreshing. Okay. So which kind of format should you choose for your engine? YAML is a half-decent choice. We could choose a binary format. Many students actually do binary formats for their custom feature, and they like double their loading speed. It's really cool. We can have a custom textual format, but we are going to choose JSON for this course. JavaScript object notation, this is extremely familiar if you have done anything with web dev in particular. It is a very common kind of, it's been around for quite a while. It is expressive enough for us, extremely popular, around since 2001. Web dev is its origins. You might have JavaScript like this. JavaScript makes it very easy to edit like JSON objects and export it to this format. It makes it very easy to send to other web services and just expect it to kind of work. It is a schema-less format, as in you can just kind of put the variable names in here arbitrarily. You don't even need to have all the right ones, or you can have too many, and it's just totally fine. You can send this to web services you've never talked to before, and you might get that to still work. When I say schema, kind of a format that requires a schema is a format in which two applications need to agree beforehand on how the data is structured and what the data means. For JavaScript, for JSON, that's not really the case because of the fact that it's human readable and it has these variable names in there. It's very easy to parse. It's pretty easy to understand. We have tools that are very good at parsing it quickly, like Rapid JSON. Newtonsoft is fantastic for C#. It is interoperable. The cons is that it is pretty verbose. Okay, you need quite a bit of grammar and structure in there to make it work. It's not quite as verbose as XML, which is kind of the king of being overly verbose. It lacks features. This is kind of the killer problem with JSON. You can't natively support comments. It's kind of a big pain. YAML doesn't have a lot of these issues. Why didn't we use it for this course? Any idea? Why don't we choose YAML for this course?
Is it proprietary?
No, it's not proprietary. I didn't. Yes.
You can't use a third party to convert it to be readable by C++ or something.
No, there are parsers, C++ parsers for YAML. And this goes back to a development question. Yes?
Just white space issues in general.
That would be probably the best reason not to use YAML. Okay? It is a bit more complex as a file format. It is a bit more annoying to work with sometimes. A bit more effort is needed. I didn't think about it. I didn't think of it. I forgot YAML existed. This is one of the happens when you're kind of under time pressure. When I was developing this course originally, we were very much under pressure to get this engine finished. So JSON was kind of pulled off the shelf so that we could focus on bigger fish to fry. But now that I have some more time, I kind of wonder if we could go back and make some different choices. Be kind of interesting, okay? But it's just as simple as that. We were in a rush to finish the course. So, JSON, though, is still a pretty awesome choice. And basically, for every keyword we add here, something you should know, for every keyword that we add, like blocking, X, Y, velocity Y, nearby dialogue, we have to write C++ code that recognizes that property and uses it somehow to bring it to life. We can start putting arbitrary things in here, but we have to write the C++ code to make that stuff meaningful. In the future, we need to get past this. In the future, we need our game designers, our users, to be able to add new features and properties, and they can bring them to life, right? Because we're not going to be there to write custom C++ for every single game, for every single feature our users might want. And so you should kind of think about how we can do that, okay? When we get to homework 7, that's going to be a huge focus. A quick aside, XML being used on The Sims 4. This was our data kind of our data representation format for The Sims 4, XML. Now, on The Sims 4, no human really ever edited XML, and that's often the case, especially as projects get really big. No human edits the XML. What we would do is in the Python gameplay code, because our engine was C++ core, very performant, Python gameplay code, I think it was Python 3 atop that C++, and then in the Python, we had some special keywords we could use and write that would basically turn into XML. We had a tool that would read our Python, generate XML from our Python. We had another tool that would let us edit that XML to give values and tuning, we called it, to different content in the game. And then when the game loaded up, there was a third tool that would go through the XML and then put those values our game designers programmed in, and they would jam it into the Python before the Python started running. So this basically allowed our game designers to edit the XML via a nice little XML editor to like adjust how long it took to eat a sandwich or how long it took to use the restroom, stuff like that. How effective certain objects were, stuff like that. Gameplay engineers would write Python. A C# tool would crawl through all the Python files and find public variables and generate XML so that we could edit them. Kind of the way Unity sort of does it. The game designers would use separate tools to edit those properties, and this really helped them avoid typos, right? Because they're not editing the text directly, they're usually selecting from a drop-down list in the XML tool. The gameplay engineers specify which options are possible in like an enum type. This enabled code completion. It was really nice. On game start, XML would be loaded by the game engine, and all the public variables would get their configured values from the XML. Or it would be baked into a binary for faster loading, stuff like that. So how can you make assets and config easier? Well, you want to reuse, reduce, and recycle if you can. So things like functions, classes, right, inheritance, all of this is code reuse in logic. We're used to this in C++. But what about assets? Well, actor templates and object copying is where we allow our game designers to reuse their stuff. Okay? In here, we have a bunch of Spartans. And notice that actually, this can be made a bit more efficient. Because notice, every Spartan we have in here has blocking set to true. Most of these Spartans are the same. But they have a couple things that are different, right? For instance, the X and the Y is different and the names are always different, okay? So what we could do to make this much more efficient, how to kind of compress this while keeping things readable, we could create a Spartan.template file. And this file can kind of have a default name, a default view, right? All of them are S, right? We don't need to keep saying S, 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 right? All the Spartans by default will have a view of S. That's what they look like in the game. They'll have a blocking attribute of true, and they'll have nearby dialog of 2 + 2 = 5. Okay? Now, what we can do is instead of illustrating and filling out all these variables for every Spartan, we can now say, I've got an actor object here. The template is the Spartan template. So just look up all those values and just give them to me. Okay? And the only thing that's going to be different for this particular Spartan is the X and Y position. X and Y, X and Y, X and Y. Okay? You could alter the blocking for one of them if you wanted to, or change the name for one of them, but they're not going to do that. Notice that we have 4 objects that are kind of sort of fitting into this like amount of space on the slide. And over here, we have like, what, 6 or 7? Anyway, it's much more efficient. It's faster to write. You can focus on what's unique about each instance instead of focusing on just copying and pasting so much stuff. There's write less data. That means faster loading, less chances for typos. It's a bit more dry. You can change the Spartan template, and you change all of the Spartan actors. And that's very powerful. Unity devs, like the 494 students, are like, oh, this is literally just prefabs. We're implementing prefabs. You're implementing prefabs in Homework 4. And that's actually kind of a fun challenge in Homework 4. One of the bigger challenges, I think. So this is called prefab in Unity. In Unreal Engine, it's called blueprint. And in general, we're just going to kind of generically call this concept a template. All right? In Godot, it's called a scene. Like everything is a scene or a node in Godot. The terminology gets quite nasty, okay? All right, so how do you implement something like this? There is a little bit of nuance. So we have our scene file, our .scene file, maybe level1.scene, and we have our template file. It's probably Spartan.template. And, we would like to kind of replace all that blob up there with the template, okay? Basically, they're the same thing. It's basically the same file. They're both JSON blocks. They have some properties. Okay? Both of these could represent an actual Spartan, not just a Spartan template. That's a template, that's an actual actor, but they're kind of the same thing, aren't they? Actually, if you look at the template, you might say, wait a second, that's kind of like an actor that we just froze and put into a test tube. We're going to clone it, okay, when we need it. So here's an idea for you. We are going to load our template files, and when we look at a new template file and read it, we're going to create an actor object, a genuine actor, but we're going to store it, okay? So we have an actor object that is stored for every template file, and when we encounter a template in a scene file, we're just going to copy that template actor. So we kind of have a library, all of these actors in test tubes. And here's your prototype Spartan. And when you see that, oh, this scene needs 5 Spartans, we're just cloning out of that test tube, basically. We're just grabbing that object we've stored, a C++ object, just copy it, okay? Very basic copy. This is called a shallow copy. And you gotta be very careful about this, okay? If our goal is in C++ to implement this actor templates feature, in my code base, I have literally a template DB .h. A class dedicated to kind of caching, loading, and kind of caching, storing these template actor objects. Here's what we can do. We can create an actor representing each template, and then when we have a genuine actor in our scene that we need to load, we can just kind of create a new actor based off that template actor that we loaded previously. So, for instance, we can have like my new actor. And it's got all of these like basic unloaded things, right? Default piece of data sentinel values. This is an unloaded actor, right? This is not loaded yet, not configured properly. We have this actor template right here. And maybe it looks kind of like this. It has an actual actor ID. It has a position. This is the default location for all Spartans, maybe. Maybe we have like a string that represents this particular actor's idle pose. And we have an attacking pose down here. That's a string. Maybe we have some piece of data inside of our actor that says which of the 2 sprites we are currently wanting to render. Okay? This already exists. We loaded up from a template file at the beginning of the game. So how do we perform a copy? We want to copy this information from our template into our actual new Spartan actor. Okay? You can do it like this. It's really, really simple. You have a new actor that is uninitialized, okay? And you simply, use assignment. My new actor equals that actor template. And so what's going to happen is we're going to do a shallow copy, kind of a default copy. And this actor, my new actor, going to copy all of this data in, and now my new actor looks like this, right? We got our ID. That's a problem, okay? We copied the actor ID from the template. If we keep doing this, we're going to have like 1,000 actors that all have ID 5. That's not what we want, okay? Be careful about that. Shallow copy is dangerous. We have position data. That's fine, okay? All Spartans start at 0, 0. That's fine. We know this. Good. It has the default kind of attacking image, okay? It has the idle image. And we have this nasty string pointer, okay? Can you see some issues that are arising already? There's actually a huge problem here. Okay, there's 2 big problems. I already said one of them, and I pointed you to the second one, okay? These right here. Do you see these pointers? So if you implement things in a certain way, in particular, pointers tend to be very scary in objects like this. This pointer in this template is set up to refer to whichever sprite we want to currently render. It's one way to do this. I think you can also probably do it with like an integer. That might be a bit safer. But when we create this shallow copy, we are literally just copying every field just as it is. We're not being any smarter than that. So the actor ID here is just totally messed up. Okay, everything is going to have actor ID 5, and these pointers are wild. In the template actor object, we have this pointer current image that is pointing to its string for image idle. It could be pointing to this one. And when we make that copy, this pointer is still pointing to this one in a totally separate object. That's crazy. Okay, if you leave it like this, you're going to get very, very confused. You might even get some exceptional issues happening. because you're not supposed to be messing with the internal, data members of another object. Maybe this is public, so it doesn't end up mattering, but this is very, very spooky, okay? Who knows what's going to happen? Your pointers are all messed up now. You also have an old kind of default actor ID, and you don't want that. So here is something that you can do to kind of fix this situation up, right? You do the shallow copy, but you need to remember to fix things up. Think about what that shallow copy means. You can set the current image to a null pointer, for instance, kind of zero it out, and you can take your actor ID, and maybe if you have something like a static integer, you can plus it to get the next one. And then, right, things are looking a bit more fixed up, all right? Not nearly as scary. Have you ever heard of something called a copy constructor? Copy constructors provide a way for you to kind of change the way that your copying is going to work. So you can, for instance, copy certain things over but not do other things. The big problem I always have with this is that you have to remember to return to the copy constructor as you add new features and variables to your data type. Because if you don't explicitly copy them over in the copy constructor, you're just going to forget about them. They're not going to be copied over. They're going to be their sentinel value, okay? And it can be quite spooky. By the way, if you want to know how this actor ID is implemented, here's one way to implement it in your .h class. You can even leave it private because it's only that data type that's going to be using the variable that is in the data type. So it still works. A takeaway, though, is this. Please think carefully about what is actually happening when you perform a copy like that. Some things you might not want to copy over, and you need to fix those things up. You can sometimes create a factory method or a factory function, which will just automatically do that for everything you create. A shallow copy is very convenient because it'll automatically copy over every field, no matter what you've got. But that means you need to fix some things up if certain things shouldn't be copied. Also, copy operations can be slow, especially as data structures grow. You can use pointers for some indirection to keep the size of your objects small. So, for instance, how big is a string? Does anyone know? Yeah.
8 bytes.
8 bytes? It's pretty chunky, okay? I think it can go bigger than that, can it? Yeah.
From my experience, I actually tested this today just out of curiosity.
That's awesome.
On Mac, it was 24 bytes, and on Linux, 32.
Dang. Oh, that's crazy. Yes?
I think that was with Windows a while ago, and it was 48.
48 bytes?
I think so.
Hey, that byte's cool. How big is a string pointer?
Aren't they usually double the size of their
No. So pointers are uniformly, typically one size on a system, which makes them very nice. They're basically like an int, kind of, right? Yes?
64-bit system, 8.
Yeah, it's like a double, right? So your pointer your reference can often be much smaller than the actual size of the data type. So you want to be a little bit careful and think about that if you can get away with it. You can make your data types a bit smaller. If you have a lot of stuff, that's really important. What about a deep copy? So you can take control of that copy operation that's happening via custom copy constructor. And it can look something like this from Geeks for Geeks. You go in and you basically have something that kind of looks like a constructor, but it takes its own data type. And it takes a reference to it. And you can kind of choose what you want to copy over from that kind of T value that's coming in. So you can copy some things, you can copy, you can ignore other things, not copy them. And you can also put in some custom logic for hooking things up if you need to. So the upside here is you can fix up the IDs and pointers if you need to. The downside is that every new field you want to copy, you have to remember to come here and add new code to actually make that copy happen. If you just keep adding fields and building your data type, you have to remember to return here, otherwise you're going to have some bugs. I despise that like nothing else. We refer to that as a maintenance site in EECS 494 because you have to keep coming back and you have to remember to come back as your data type evolves. And no one remembers to come back, okay? An intern on your project is just going to add a variable. They're not going to know what a copy constructor is or that they have to fix it up, okay? Guaranteed bugs. A huge faucet of continuous flow of bugs. maintenance sites are, okay? So I'm not super high on them personally, but whatever. Performance considerations. Copying data can be slow. We're gonna finish up very quickly. Thank you for your patience. It depends on how much data you got, okay? So small actor, you can kind of go in, and it looks like, thankfully, I put down 24 bytes, okay? 68 bytes total. All right, sweet. But you can keep adding stuff. Homework 7, we have an actor that is 664 bytes. That's getting kind of chunky, all right? Your goal is you want to make as few copies as possible. If you need to reference an object but don't want to make a copy, you can kind of point to that object instead. Consider doing a pointer, 8 bytes each. And be wary of your functions. Pass by value, right? You already kind of know this from 280, 281. But pass by value, that is really scary right there. That's going to make a copy. It could slow you down, especially if this is something happening every frame. Pass by reference, you're copying the pointer, kind of. Okay? And so it's going to be a much smaller thing and should be quite a bit faster as well. Okay? Reference, but you can also pass in a pointer. I think like a lot of old C APIs didn't really have this concept of passing by reference. I think this might have been a C++ thing or maybe a late C thing. And so you see a lot of function signatures that are like this. It's kind of sort of the same thing. How many copies of my actor exist here? Let me see. All actors, my actor. Any ideas? This shouldn't create an actor just by creating the container. This does create a copy, and then this is going to create a second copy, okay? Which might not be what you want. It might not be something you need. So we have one copy here, and then a second copy that actually gets put onto the heap by the container. The container is going to manage that memory for you. Okay, how many copies of actors exist now? Yeah, one. Yep, bingo, right? We're creating a copy, we're throwing it onto the heap, and then we're actually putting that pointer onto the container. All right, so only one copy of the actor exists. Technically, 2 pointers also exist. Pointers are super small. They're not going to be 600 plus bytes, and so you can often kind of just ignore them. Cool. All right, everyone. There are a lot of fun experiments to be done. There are a lot of ways to pass these homeworks. The most important thing is for you to get in there and experiment, okay? Gain some confidence. Poke and prod things. Try different ways of doing things. See if you get a performance improvement. See if you don't, okay? When you run into bugs, when you spend time debugging them, that is not wasted time. So long as you dig a bit deeper and try and learn what actually happened and why did I get confused. That is all invested time. That's not wasted, okay? And you'll get a good return if you dig deeper and put in that time. I hope you'll enjoy it and don't get too stressed out. The best thing to do here, start your assignments early, okay? Work on it with other people. Don't copy code, but talk with your classmates in Discord, in person. And you'll find that you're completing these assignments without getting too stressed. You get stressed, and your learning outcomes are out the window, okay? But if you can complete this stuff, work on it early, I think you'll be just fine. You'll have a good time, too. I think you'll enjoy it, okay? Okay, I've got 2 hours of office hours. I'll be chilling here. Ask me questions if you want. If you got troubles with homework 4, let me know. I can often look up and get more details about what happened on a recent submission for you, which is pretty cool. And we will see you on Monday, okay? Have a good weekend. And we got more office hours pretty much every day. Sunday, remember the big block office hours, okay? Don't fall too far behind. We'll see you later. Bye-bye.
Strings are actually 40 bytes, not 48.
40 bytes?
40.
Okay. I looked up 24. I got 24 somewhere. I don't remember where I got it.
Yeah.
But yeah, it seems like,
Platform specific.
yeah, 40 bytes, huh? Huh.
I also found out Visual Studio that you visualize the memory layout.
Yeah. Oh, that's really cool.
Yeah.
Why isn't string, more like a vector of characters. Is that like, what's going on here? Why is it just 24 bytes by default?
I mean, there's the
Shouldn't it like increase by?
pointer to the character. There's the 8 bits or 8 byte for the size, 8 byte for the capacity. I think would be it.
Okay. Why is it so big on some platforms? What are they?
I'm not sure.
Are they like caching something to make it faster somehow, or?
It doesn't let you like look in at what it's actually doing. Try like seeing if you could like open up some like.
Yeah, there's got to be a way to do it, because I know I've accidentally opened up some of those like standard library data types in a debugger, and I've seen some of those weird properties in there. So there's got to be a way to do it. But okay, all right, everyone watching online, we'll see you later, and yeah, have a good weekend. Bye bye.